The most basic characteristic that you'll be interested in, and what the surgeon is interested in an endoscope, is the field of view. This is an arthroscope, fairly typical. It's 4 millimeters in diameter. Now, if I look through this, I see a very wide view. You know, if I move my finger there, I can see my finger here. If I move it on the other side, I can see my finger there. So if I define an angle on 2 sides of my finger, that's field of view. So it's a fairly basic characteristic of endoscopes.
What's a typical range?
A typical range for an arthroscope is somewhere 90 to 110 degrees.
So it varies by application.
Absolutely. So a laparoscope, which is used for abdominal surgery, typically has a field of view of 70 degrees. And that's a really good point. So field of view is not a figure of merit. It's something that is a property of the endoscope, and such that the surgeon wants a typical field of view. They want 90 to 110 field of view on their arthroscope, and they want their 70 degree on the laparoscope, or else they're going to be disoriented. Another way to think about field of view is magnification. If we had a small field of view in this instrument, everything would look bigger because we'd be filling the image on the monitor with a smaller part of the anatomy, so it's going to be magnified more. So if a surgeon all of a sudden had a 70 degree field of view with an instrument like this, they would think maybe that the scope was too close to what they were looking at, or even worse, there's something wrong with the patient's anatomy if they knew, no, I'm definitely the right distance away, and that liver is way too big. We got a problem. Anyway, so if you were talking about, you had, I was looking at you, say, Nicholas, if we had a wide field of view, you might look like this when I look through the instrument. If we had a narrower field of view, you might look like this. The second characteristic that's really important, just a minute ago, and that's direction of view. This is, in a way, similar to field of view, where it's not a figure of merit. It's something that the surgeon needs to have consistency. You'd think it would be pretty straightforward. This particular arthroscope that we're looking at is a 30-degree direction of view, which means that the angle between the axis of the endoscope and the center of the field of view subtends an arc of 30 degrees. What this allows the surgeon to do is look to the side of objects and also effectively increase the field of view by being able to rotate and scan around without having to move the endoscope. So again, an arthroscopist with an arthroscope in the knee wants that consistency. When it's a 30-degree scope, it should be 30 degrees. The third characteristic is a little bit more difficult to understand, but still very important. It's called the parent field of view. I'm going to pass this scope around and have you look through it. And actually what I'll do, take this tissue. What I want you to do is just put the tissue around the tip of the scope so you're not confused by looking at anything. And tell me what you see. circle with a little notching. Good.
It's pretty concentric.
Yep. Hey Jim, can you? Okay, so now I want to pass this laparoscope around. Have you do the same thing. Tell me what you see there.
Is that 10 millimeter?
That's a 10 millimeter.
Circle.
Circle. Any difference between the circle and the arthroscope?
It's bigger.
That's the right answer. So we're looking at through the scope. You have no idea what the field of view is because you've covered it, but you're seeing a bigger circle. The size of that circle is proportional to the apparent field of view. Okay, so who cares? The reason we care is that when you connect up these endoscopes to a camera system, the size of that circle translates to the size of the image circle on the monitor. For example, here's our two monitors, same size monitor, and say with the 4 millimeter arthroscope, you'll see a circle that looks like this. We don't know what's inside of it, you know. Something's going to be inside. We're not even caring about that. With the 10 millimeter, with the same camera, the same everything else, what you'd see is this big.
So will it crop like that, or can you pull back so that you
No,
see
there's
the
nothing
entire
you can
image?
do. It will crop like that.
Okay.
You know, you can change things by changing the camera system or changing the video coupler. You can't. Or if you had a zoom coupler, you can change it. But for this exercise, keeping everything the same, this circle will be bigger than this circle.
Mm-hmm.
So now, again, it's about what a surgeon is used to.
Right.
We want to keep everything consistent. We want, you know, from one day to the next, they want to see the same size circle every time they use their 10 millimeter laparoscope versus their 4 millimeter arthroscope. A measure of that is apparent field of view. So it seems to be kind of an esoteric measurement, and most people have never heard of apparent field of view, but you can see how important it is. So we can't, you know, you could say, okay, this fills a half of the monitor, this overflows by 25%, but if we started quantifying the apparent field of view like that, then you have to say, okay, with a half-inch format camera and a 27 millimeter focal length video coupler, you have to have all these caveats and specifications for the measurement. By using apparent field of view, that's all we need to quantify the endoscope.
Going to see how easy it is to measure the field of view and direction of view. Simply move the outside circle so that it is coincident with the outside of the field of view and record the position from the digital micrometer. Move the target in so that the inside circle is now coincident with the field of view and make another reading. Clicking the small green arrow calculates the field of view of the endoscope. To compute the apparent field of view, use the up and down arrows to make the green circle coincident with the outside of the field of view, and the apparent field of view is automatically computed. Direction of view is simply read off of the goniometer table and input into the device.